In this section, we will dive into the use of truth tables to display prepositions. We ended the last section by looking briefly at several of the logical operators we can use to combine prepositional statements. In this section, we will take a closer look at how these operators work and how truth tables help us to visualize the truth value of statements combined using these operators. Truth tables are used in logic as visual representations of prepositional statements. We use truth tables to determine the true value of a whole sentence given the truth value of its parts. We don't write the full preposition statement in a truth table to avoid it becoming cluttered and unreadable. Instead, we use letters to represent these statements. The commonly used letters in discrete math for truth tables are P, Q, R, and S. Let us begin by looking at a simple negation example. In this example, the statement, "the sky is blue," is denoted by the variable P. The negation of P will be "the sky is not blue," denoted by not P. Each row of truth table represents a truth value assignment, an assignment of true or false to each variable. In this case, our variables are P, which represent the statement "the sky is blue," and not P, which represent the statement "the sky is not blue." Note that the number of rows depend on the number of variables to be evaluated. One variable, in this example, the variable P, yields 2 to the power of 1, which is 2 rows, and so on and on. When creating a truth table, we want to display all possible true value assignments for the statements without duplicating any. So we adapt a convention to guarantee that. The column under the first sentence variable gets a value of true for half of the rows and false for the other half. The last column of a truth table always alternates between truth and false. Now, let us look at the conjunction of two prepositions and the truth table that visualize this. In this example, we'll assign the variable P to the statement, "the sky is blue," and the variable Q to the statement, "oceans are blue." The preposition "and" Q is called the conjunction of P and Q, and it's true when both P and Q are true. The resulting truth table of P conjunction Q looks like this. Notice how we employed our convention for the first column, assigning the first half of the row with the value of true and the second with the value of false. Our convention for the second column, we alternate true and false. Notice that P conjunction Q is true when both of the parts are true. So, let us recap what we have just seen. P conjunction Q is true when both of these variables are true. Here in row 1, we would read the output of P conjunction Q as "the sky is blue" and "the ocean is blue," with an output of true, truth. In row 2, we read this as "the sky is blue" and "the ocean is not blue," as having an output of a false truth. In row 3, "the sky is not blue" and "the ocean is blue," as having an output of false truth. And row 4, "the sky is not blue and the ocean is not blue" has a false output. Be sure to review if you do not get it straight away before moving on. Now that we have walked through a conjunction example, let us move on to a disjunction example. This statement is called the disjunction of P or Q. Here we join two prepositions with the word "or." Listen to this statement. The preposition P or Q is called the disjunction of P or Q. P disjunction Q is false when both the variables are false and true when either of the variable is true. Now pause the video and try constructing a truth table for this disjunction. Example, where P disjunction Q is false when both the variables are false and true when either of the variable is true. The resulting truth table of P conjunction Q looks like this. Notice it's similar to the truth table representation for conjunction, except that the combined statement P or Q is considered true if any of the variable is true. Take a moment to study this example if you do not get it right away. We will move on to the third section in the next video.